times 4 and get a 16, or you can take -4 times -4. Okay, so you have to remember that when we do square roots, we put that little plus or minus. So today we're going to solve square and cube root equations. So step number 1, you always want to make sure that you have the square root or the cube root isolated. And by that, we mean when we say isolated, that means you have it all by itself. So when you look at example A, it says the square root of x equals 7. Is the square root of x all by itself? Is there anything else on that side of the equal sign with it? No, it's all by itself. Okay, so how do you unsquare something? Or how do you unsquare root something? You square it. So we're going to square both sides. So the square root of x, the quantity squared, I don't know if you guys can see that or not. The square root of x, the quantity squared, is just x. And 7 squared is 49. Well, we have to check each one of our answers because weird stuff happens when you square and cube stuff. So let's see. If I let x equal 49, well, does that, the square root of 49, actually equal 7? Is that a good check? Yeah, that works. Okay. Let's look at example B. Reagan, you with us? Example B has x minus 3. The quantity is raised to the 1/2 power. Everybody pick your heads up. So what's another way to write to the 1/2 power? If something is to the 1/2 power, that means it's the square root. So really you have x minus 3 under the radical, or the square root of x minus 3 equals 5. Is there anything else on the left side of the equal sign with the square root symbol? No. So the square root is isolated, right? There's nothing else over there. So how do you unsquare root something? You square it. So we're going to square both sides. So the square root of x minus 3, the quantity squared, is just x minus 3. And 5 squared is 25. And now we're just going to solve this by adding 3 to both sides. So x equals 28. We have to check this. So let's check. So 28 minus 3 to the 1/2 power equals 5. Well, what is 28 minus 3? It's 25. And 25 to the 1/2 power is the same thing as saying the square root of 25. And is the square root of 25 5? Yes. Are we good with that? Okay. Am I going too fast? Luke, are you saying this is hard? Did I just hear you say that? Lip that? Okay, because this isn't hard, I promise. So example C, is the radical all by itself? Yes. So if we want to do the unsquare root something, we have to square both sides. Square both sides. So that gives me 2x minus 1 equals, what is 4 squared? 16. We're going to add 1 to both sides. So let's see. That leaves me with 2x equals 17. Divide both sides by 2. And I'm going to leave it just like that. X equals 17 halves. X equals 17 halves. Well, I have to check it, right? I have to plug it in up top and check that. So when I do my check, I have the square root of 2, and I'm going to write it as 2 over 1 times 17 halves minus 1. I'm going to say that equals 4. Remember with fractions, when you're multiplying fractions, you can cross reduce. So the 2's cancel out. The numerator 2 and denominator 2 cancel out. So this really just says the square root of 17 minus 1 equals 4. Well, what is 17 minus 1?
16.
So that says the square root of 16 equals 4. Is that true?
Yeah.
Yes, it is. Are we okay with that?
Yep.
Okay. Sir,
I got V-Bucks.
that's excellent. Are we ready to keep going?
Of course.
Okay. What does this actually look like? We have to write this as an equation. So what's being put underneath the radical? Look at this and tell me what's going underneath the radical. So I hear a lot of people saying stuff, but nobody's saying it loud so we can write anything down. What number is being raised to the 1/2 power? Not, is 3x being raised to the 1/2 power? Shh. Listen to me. What term has the exponent on it? Only the x. The 3 does not. Is it in a parenthesis? No, it's not. So x is the only thing that's going to be under a radical. So it's really 3 times the square root of x. And then outside of that square root is -4 equals 20. Because the only thing that's really being raised to the power of 1/2 is that. That's your radical, okay? So let's see. The only way that we can get the radical all by itself, well, first we're going to add 4 to both sides. So that's 3 times the square root of x equals 24. What do I need to do next? I'm trying to get the square root all by itself. It's not by itself yet. It's not subtraction, it's a times. Divide. So the square root of x equals 8. Now we're going to square both sides to get rid of the radical. Square both sides. So that means that x equals 64. I'm going to check it. So let's see. 3 times, I'm going to just write square root because that's what we know it is. The square root of 64 minus 4 equals 20. Well, what is the square root of 64? 8. So that's really 3 times 8 minus 4 equals 20. What is 3 times 8? 24. Does 24 minus 4 equal 20? Yes, it does. You have to remember how to turn a fractional exponent into a radical, okay? That was your whole lesson. It's only with practice, hon. It's only with practice. What do I need to do first? I'm trying to get the radical all by itself. We always undo addition or subtraction. We always undo addition or subtraction first. -7 from both sides. So when I subtract 7 from both sides, I have 2 times the square root of x plus 5 equals, let's see, 13 minus 7 is 6. Now what do you want to do? Divide both sides by 2. Excellent. So that's the square root of x plus 5 equals 3, because 6 divided by 2 is 3. How do I get rid of the square root? I square it. That is not times by 2. I square it. Whatever you do to one side, you do to the other, okay? So the square of a square root just makes it, they cancel each other out. We've shown that because 2 times 1/2 is just 1. So this gives me x plus 5 equals 9. Subtract 5 from both sides, and I find out that x equals 4. X equals 4. So let's plug that in and check it. So 2 times this, whoops, sorry. I don't know what you're doing over there, but can you guys just stop? So 2 times the, let's see, square root of 4 plus 5 plus 7 outside the square root equals 13. Well, what is 4 plus 5? 9. So I really have 2 times the square root of 9 plus 7 equals 13. What is the square root of 9? 3. So 2 times 3 plus 7. Does that equal 13?
Yep.
Yes, it does. 6 plus 7 is 13. Okay. What are you thinking?
If I could make V-Bucks out of wood.
If you could make what out of wood?
V-Bucks out of wood.
Okay. I'm hoping that you're starting to focus on math. Okay. What are we going to do here? Add 4 to both sides. Who said that? Who's me? Good job, Zach. Add 4 to both sides. So 5 times the square root of 3x minus 2 equals 40. Next step, Kane. How do you get rid of that 5 out front? It's no different than the 2 out front before or whatever. We just keep doing the same thing over. You guys aren't paying attention. Shut. Kane. Got Kane. What? Divide by 5. Thank you, Luke.
8.
Square root of 3x minus 2 equals 8. Kane, Luke, how do I get rid of the radical? You have to square it. Whatever you do to one side, you have to do to the other. So 3x minus 2 equals 64. Next step, Parker, how do I get 3x all by itself? How do I move away that 2? You add it to both sides. 3x equals 66. Last step, Josue, divide both sides by x equals 22. I have to check. So I have the square root. 5 is on the outside. 3 times 22 minus 2, all under the radical, minus 4 equals 36. Well, what is 3 times 22? 66. 66 minus 2 is 64. Minus 4 equals 36. What is the square root of 64? So 5 times 8 minus 4 is 36. Is that true? Is 40 minus 4 36? Yes, it is. Are we good with that? Yes or no? Who needs that up there still?
Yay.
Okay. This is a cubic. This is a cubic. So I still have to get the root all by itself. So I'm going to subtract 5 from both sides. That gives me the cube root of x minus 7 equals 4. To get rid of the cube root, I have to cube both sides. I have to cube both sides. So that gives me x minus 7 equals, well, 4 cubed is 64. So x minus 7 equals 64. I'm going to add 7 to both sides. X equals 71. I need to check it, and I need to write small. So let's see. For my check, I have the cube root of 71 minus 7 plus 5 on the outside equals 9. Well, 71 minus 7 is 64. And the cube root of 64 is, it's 4. And 4 plus 5 is 9. 4 plus 5 is 9.
Looks like
It looks like a what?
it checked out.
It does check out. What about this next one? Subtract 9 from both sides.
Yeah.
Okay. This says that the square root of 3x plus 5 equals negative 9. When can the square root ever, like when does the solution of the square root ever equal a negative?
Never.
It doesn't, right?
How do you fix this?
Well, this has no solution.
What?
Yep.
So if it ends in 0,
And not if it ends in 0. It depends on, like, when you isolate the radical, when you isolate the square root, if you end up like the square root equals a negative, you know that there's no solution. Okay. Are we good with that?
okay.
Okay. This next one is going to ask us to graph. So when you guys first started learning about systems, you learned how to, like, the first method that we use to teach you systems is by graphing. It's not a great way to solve equations because if it doesn't intersect exactly at a grid line, then it's really hard to tell exactly what your answer is. But we're going to use what we know about square root functions and what we know about linear functions, and we're going to graph both of these. So let's graph the linear one first. I'm going to graph the linear function and a green pen. So this is written in the form y equals m times x plus b. That means I'm going to begin on the y-axis at positive 1, and the number attached to my x is a 1. My slope is up 1 and over 1. So I'm going to do all of that first. So I'm going to go to my graph. I'm going to begin at positive 1, and then from there I'm going to go up 1 to the right 1, and I'm just going to keep repeating that. I could also go down 1 and to the left, and I'm going to plot those points. I'm just going to plot those points. So this looks like this. This is my linear function. Are you guys okay with that?
Oh, I'm pretty okay.
Okay, so let's talk about the square root function. Aaron, when I have a square root function and there's something taking place inside the function, does this plus 3 mean that my starting point moves to the right or to the left? It moves to the left. So this is going to move left 3 units. That means my starting point is now going to be negative 3, comma 0. Negative 3, comma 0. I want you to remember the pattern for a square root function. If I go 1 unit to the right from the starting point, I'm going to go up 1. If I go 4 units to the right, the square root of 4 is up 2. If I go 9 units to the right, the square root of 9 is up 3. So let's graph this and use our pattern. So I'm going to begin at negative 1, 2, 3, 0. This is my beginning point, my starting point. And I know that if I move 1 unit to the right, I go up 1. If I move 1, 2, 3, 4 units to the right, I go up 2. And if I move 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right, I go up 1, 2, 3. Where is my point? It just kind of disappeared. Okay, so where do the two lines intersect? Yeah, they intersect at the ordered pair 1, comma 2. Okay, so that's solving it graphically. That's solving this graphically. So what did we say our solution is? Well, our solution is the ordered pair 1, comma 2, because that's where the two graphs intersect. That's where the two graphs intersect. I'm going to make it a little bit smaller so you guys can see both. I'm sorry. Did everybody get the graph? No? Will, do you want me to do it with you again? Walk you through it, or you got it? So we started with the starting point at negative 3, and then we moved over 1, up 1, and then we went back to the starting point over 4, up 2. Do you see that, Will? And then I go back to the starting point, and I go to the right 9, up 3. Okay? All right, so next it asks us to solve it algebraically. Well, if both of these functions equal y, then that means they equal each other. So I'm just going to rewrite this as the square root of x plus 3 equals x plus 1. Because if this equals y, then I'm just replacing it right here. I'm replacing y with that value. So I have to square both sides to get rid of that. But remember, when you square a binomial, you have to FOIL. You have to FOIL. So this becomes x plus 3 equals, so this is, I just want to show you what this looks like. That's what's really happening right here. So x squared plus 1x plus 1x plus 1, which equals x squared plus 2x plus 1. That's a quadratic. How do we solve quadratics? We set them equal to 0. So I'm going to subtract x and 3 from both sides. And when I do that, I get 0 equals x squared plus 1x minus 2. Well, that can be factored. This factors into x plus 2 times x minus 1. Well, if x plus 2 equals 0, then x is negative 2. But if x minus 1 equals 0, then x is 1. These are both of my solutions. These are both of my solutions. It says that x can be -2 or x can be 1. Well, we know that when x is 1, y is 2. We know that that one works because we can see it on our graph. You guys know that that one works because you can see it in our graph. But when x is -2, I'm right here. Am I touching either point of my line? No, I'm not. It's not going to be a solution, but I need to show you why. If I let x equal -2, I have -2 plus 3 equals -2 plus 1. That's what we started with. Well, -2 plus 3 is 1, and -2 plus 1 is -1. This says the square root of 1 equals -1, and that's not true. So this is not true. They don't match, right? So the contradiction is that x cannot equal -2. This is called extraneous. This is called an extraneous solution. It's called extraneous. We're going to do flip over. We're going to do exercise 3, solve example A and B, and then we're going to be done. Okay, we'll finish our notes up tomorrow.
Yeah.
We're going to do example A and B, and then we'll finish our notes up tomorrow. So it says, oftentimes roots are introduced by various algebraic techniques that for one reason or another are not valid solutions. And it's because when you square or cube something, sometimes you make the negatives go away, right? Like when you square something, the negatives cancel out. So these solutions that you get are called extraneous, meaning that they might work. Like when you solve it, it looks like it works. It looks like it's actually a solution. But when you plug it back in to the original equation, you find out that it doesn't work. Okay. So those are called extraneous. So we're finding the solution set of each one of these following, like each one of these 2 examples, and we're going to reject any extraneous solutions. So anytime you solve a square root equation, the only way to get rid of the radical is to do what, Parker? You with me? Does it look like you were sleeping? How do I get rid of the square root? What do I have to do to both sides? And square it. Okay. So when I square the square root, it like evaporates, right? That melts it away. Do you guys remember why that happens? I'm just going to write off to the side because really the square root is 2x minus 3 to the 1/2 power. And when I take that and I multiply it by 2, half of 2 is 1, right? It cancels out. It's to the same thing as a power of 1. But x minus 3 squared, well, that's x minus 3 times x minus 3. Do not do any voodoo math here. Let's see. X times x is x squared, right? Minus 3x plus 9. Some of you guys are not paying attention. I've lost you. So x squared, go ahead.
Minus 6x plus 9.
Thank you, sir. How am I going to solve this? What do I need to do?
Add 3.
Add 3 to both sides
And 2x.
and subtract the 2x. Because it's quadratic. So 0 equals x squared. Keep going. Plus 12. That's right. So do you want to factor this or use the quadratic formula? It factors nicely. It factors nicely. What are 2 numbers that you can multiply together to get 12, that when you add them, you get -8? 6 and 2. They both have to be what, Colt? Negative. X minus 6 and x minus 2. Those both equal 0. So remember that if your factors are negative, your roots are positive. So that means that x equals 6 or x equals positive 2. One of those does not work. One of those does not work. We have to plug it into the original. So let's check it. So the original equation, I have 2 times, I'm going to use 6 first. We'll check 6 first. 2 times 6 minus 3 equals 6 minus 3. So let's see. What is 2 times 6? Minus 3 is? So I have the square root of 9 equals, and what is 6 minus 3? 3. Does the square root of 9 equal 3? Yes, it does. Let's check it the second equation. Let's check it when x equals 2. So I have the square root of 2 times 2 minus 3 equals 2 minus 3.
Yeah, that's right.
So what is the square root of, what is 2 times 2?
4.
Minus 3 is?
1.
And 2 minus 3 is?
-1.
Does the square root of 1 equal -1?
No.
No. So that means that this,
It's not right.
yeah, we just put ext next to it. We put a slash through it, and we say that it's extraneous. And I'm going to put a do not equal, like a slash through my equal sign. Okay. Extraneous, remember, just means that it's extra. It came about from squaring a negative, but it's really not a solution. Okay. It's kind of lame. Yep. We've got one more example. One more example. Okay. So I have to get the radical all by itself. I have to isolate it, right? Make sure there's only this on one side. So what do I need to do to move away? Add 2 to both sides. So 2x plus 2 equals the square root of x plus 6. Nathan, how do I get rid of that square root side on the right? What do I have to do to both sides? I have to square it. Yep. I have to square both sides. Remember that when I square a binomial, it's really saying 2x plus 2 times 2x plus 2. Okay. 4x squared. Well, 2x plus 2x, like 2 times this, 2 times x is 4x plus 4x, which is 8x plus 4 equals x plus 6. What am I doing now? I'm subtracting x and I'm subtracting 6. Do you see that? So we have to set one side equal to 0. The 0 is on the opposite side this time. Do you see that, Tyler? It's on the opposite side. That's why it's messing you up. Okay, so that gives me 4x squared. 8 minus 1 is plus 7x minus 2. Yeah. So let's see. I'm looking for 2 numbers that multiply together to give me -8. That when I add them, I get 7. 8 and -1. So 4x squared plus 8x minus 1x minus 2. Do you guys remember doing this? Vaguely? I know you like the box better, probably. So what's the greatest common factor between 4x squared and 8x? 4x. What's the greatest common factor between -1x and -2? -1. When I take a 4x out, I'm left with x plus 2. When I take out my -1, I'm left with x plus 2. So when we factor this, we find out that either 4x minus 1 or x plus 2 equals 0. Well, if 4x minus 1 equals 0, what does that give me? It gives me 4x equals 1 or x equals 1/4. If x plus 2 equals 0, that means when I subtract 2 from both sides, that x equals -2. Those, ooh, I just ripped out my earring. Those are my 2 solutions. We have to check them. We have to check them. I know that you guys have got to be running out of room on your paper. I'm trying to write small, sorry. So we have to check them. Let's check the whole number first, or the integer first, okay? So we're going to do 2 times -2. 2 times -2 equals the square root of, I'm right here, honey, -2 plus 6 minus 2. Huh?
You put my grade
Which one?
for the homework?
For today?
No. For
The one that I wrote on my pocket?
Yes.
I have not even used the bathroom yet today.
Alright.
Sorry.
You're fine.
Haven't had 3
I
seconds.
just wanted to remember.
I will. Thank you. So 2 times -2 is what? 2 times -2 is a -4 equals, what is a positive 2 or a -2 plus 6? So I have the square root of 4 minus 2. What is the square root of 4? So does -4 equal 2 minus 2? So this one doesn't work. So this one is extraneous. Let's check the next one. 2 times a positive 1/4 equals the square root of, I'm just using this equation right here, 1/4 plus 6 minus 2. So calculators, what's 2 times 1/4? It's 1/2. I don't know why I put a big old dot there. It's 1/2. And I'm going to write it as, actually, I'm going to write it as a 0.5 because that'll help you on the other side. Okay. 6 plus 1/4 is really 6.25 minus 2. Take the square root of 6.25 in your calculator. What is the square root of 6.25? It's 2.5 minus 2. What's 2.5 minus 2? 0.5 equals 0.5. So this is the only solution that works. This is the only solution that works. Okay. So you guys are going to do, I'm going to go to your homework really fast. I'm going to go to your homework. We'll finish these notes tomorrow. I'm going to tell you. I have to stop this.